Alright guys, so now let's start the mechanism, which is one of the most important chapter and one of the most important part of edXL levels chemistry, both unit 4 and unit 5 and unit 6 as well. So let's start. There are two types of mechanism, which one is this SN1 and SN2. Both of them are really important. So when does actually SN1 happens and when does actually SN2 happens? We know about the halogenoalkanes, right? 1 degree halogenoalkane, 2 degree halogenoalkane and 3 degree halogenoalkane. In 1 degree halogenoalkane, the carbon atom which is attached to the halogen atom, let's say the carbon is attached to the chlorine atom, the carbon which is attached to the chlorine atom, that particular carbon will be attached with only one another carbon atom, or it can also be attached with no carbon atoms. Whereas in 2 degree halogenoalkane, the carbon atom which is attached to the halogen atom or chlorine atom will be attached to two carbon atoms. In the same way, in the 3 degree halogenoalkane, the carbon atom which is attached with the halogen atom will be attached with three different carbon atoms. So this is the main difference of 1 degree halogenoalkane, 2 degree halogenoalkane and 3 degree halogenoalkane. I've actually given you a brief idea. If you want to know more about these halogenoalkanes and their degrees, you can watch another video of us where we have explained 1 degree halogenoalkane, 2 degree halogenoalkane, 3 degree halogenoalkane. Please let us know in the comment box if you want to know more about this halogenoalkane. So we'll make a separate video for you guys to make you understand this part. Now, without wasting any more time on this basic thing, let's move forward. So basically, which one goes through SN1 and which one goes through SN2 mechanism? The 2 degree halogenoalkane can go both SN1 and SN2 mechanism, and 1 degree halogenoalkane always goes for SN2 mechanism, and 3 degree halogenoalkane always goes for SN1 mechanism. Now, to determine whether a 2 degree alkyl halide follows, so 2 degree halogenoalkane both times it follows SN1 and SN2. So when does it take place SN1 mechanism and when does it takes place SN2 mechanism is something that we will figure out, and it can be figured out using by observing the rate equation order. We have learned about the order of the rate equation, right? You can observe the order of rate equation to determine whether the 2 degree halogenoalkane will undergo SN1 or SN2 mechanism. You can also observe the optical activity and chirality changes in the product, how the chirality changes in the product. This is how we can figure out. Though figuring these three things is not important for our syllabus, I've given you this extra information in order to make you guys understand more about this particular thing. Now moving on to the SN1 mechanism. The only thing that we have to understand is the SN1 mechanism, and the thing that I'm viewing right here is very important. You will have to memorize from this part to this part for your exam, because this is a very common question, and this diagram is also very important. You will have to be able to understand and draw this diagram, because this is a 6 marks question that comes nearly in every exam, as well as this 4 mark written question. So make sure you're understanding as well as memorizing and practicing this drawing as well. So now let's understand here. Basically, in the SN1 mechanism, you can see this chlorine is a positive, chlorines are positively charged, right? Sorry, the carbon atom is positively charged, right? And this bromine is negatively charged, right? The carbon is positively charged and the chlorine is, sorry, the bromine is negatively charged, and we know this bromine is a very good leaving group. So this carbon and this bromine breaks up with each other, and now this carbon has become electropositive carbon atom. Okay, this carbon is electropositive carbon atom, or you can also say this carbon, as there is no bromine attached with it, it has become a carbocation. Now this carbocation will be attacked by OH minus nucleophile. This OH minus nucleophile will attack this electropositive carbon atom, and or you can also say this carbocation. So the carbocation can be attacked by this OH minus nucleophile from either sides, from this side as well as this side as well, from the left hand side and as well as the right hand side, from this left hand side as well as this right hand side. Both the right hand side and left hand side, they can attack the electropositive carbon atom. That's why it produces two enantiomers. One is the positive enantiomer and the other one is negative enantiomers. So as this nucleophile can attack the carbocation from both the sides with equal probability, it will produce positive and negative enantiomers of equal concentration. Both of them will have equal concentration. So we know if they have equal concentration, and if the positive and negative enantiomers are of equal concentration, it produces a racemic mixture that we have seen previously in our chiral molecule video as well, and optical isomer video as well, right? If you haven't watched that video yet, please go and watch that video. I will put the playlist of the whole unit for organic chemistry in the description of this video. Now let's understand this right. At the end of the reaction, the product mixture shows no optical activity. Why no optical activity? Because the mechanism involves a planar carbocation. This carbocation is planar, which allows the OH minus nucleophile to attack from either side. They can attack from the left hand side as well as the right hand side with equal probability. As a result, an equal concentration of positive and negative enantiomers are formed. As equal concentration of positive and negative enantiomers are formed, which leads to a racemic mixture. The things that I have previously make you guys understand in the last video. So now moving on, we will learn about the SN2 mechanism. Now let's understand the SN2 mechanism. So what is actually SN2 mechanism? In the SN2 mechanism, we know the positively charged carbon, the negatively charged bromine. Okay, they are positively and negatively charged bromine. In the SN2 mechanism, they don't break up with each other at the first part. What happens is, when both of them are together at that particular time, the OH minus nucleophile comes and attacks the carbon, the carbocation or the carbon atom from the left hand side. These OH minus nucleophile cannot attack from both the sides. It will only attack from the left hand side. It will not be able to attack from the right hand side, just like the SN1 mechanism. In the SN1 mechanism, we have seen both of them are attacking from both the sides, from the left and right, but here it will only attack from the left hand side. And when it will attack the left hand side, this OH will get attached with this carbon. Now as this carbon and this bromine is positive and negative, now both of them will break up with each other, and this bromine will become a nucleophile which will get out, and it is remaining just like this, attached with the OH. So this is how it takes place. This is the transition state. Okay, this is the transition state. Now at the end of let's understand the explanation, and you have to memorize this explanation as well as this drawing as well. Now at the end of the reaction, the product mixture shows optical activity. Why optical activity? Because it has only produced one enantiomer, unlike the previous one which has two enantiomers, because the OH minus nucleophile could attack from both the sides. Here it is attacking from one side, so now it has produced only one enantiomer. That is why it is showing optical activity. Opposite to that of the reactant, opposite to this reactant, it shows the optical activity. This happens because the OH minus nucleophile attacks the positively charged carbon from the side opposite to the leaving group. This leaving group is on the right hand side, and OH minus nucleophile attacks from the left hand side. That is why this product will show optical activity opposite to the reactant. Opposite to the reactant, because OH minus nucleophile attacked from the opposite side of the halogen atom. This is the main reason. This results in a single optical isomer with an inverted stereo structure compared to the reactant. So basically we are done with both the SN1 and SN2 mechanisms, which is really important for your unit 4 and unit 5 organic chemistry. Please watch this video once again if you don't understand anything, and also comment down below. I will love to answer your questions and make few more videos if you have any issues in your basics. And if you haven't watched our previous video regarding stereoisomerism and structural isomerism, please go through our videos. I will put the video playlist in the description box.